Hi, I'm Axel from the I+D Pharma Group. We're a research group interested in the design and formulation of nanocarriers for the treatment of diabetic eye diseases. Why do we care? Well, it's very simple. 8.5% of the adult population worldwide suffers from diabetes. This is a problem because it not only affects the liver, like most people think, but it also affects all the organs in the body. It affects in particularly the eyes. And vision is something super important for everybody. We use it to navigate the world. In our case, we're looking at diabetic retinopathy. This is something that happens when the blood glucose levels are too high and retinal degeneration starts to happen. I want you to think for a second that the rest of this presentation would be like this, because you have become blind. In the current case, 80% of the people worldwide that have been living with diabetes for more than 10 years end up having loss of vision. This is caused by diabetic retinopathy. In the sorbitol accumulation, which is the product of glucose being transformed into sorbitol, and then sorbitol needs to be transformed into fructose, the sorbitol is a very important molecule. This molecule is not permeable to the cell membrane, and it is made by the aldose reductase enzyme. This process doesn't happen in a healthy body. However, when the blood glucose levels are too high, this different pathway opens up and sorbitol production starts. However, the path from glucose to sorbitol is a lot faster than the path from sorbitol to fructose. Therefore, we get this accumulation. And as sorbitol accumulates inside of the cells, it creates osmotic and oxidative stress, leading to cell death. However, we have a solution. The solution is called iparostat. It's a small molecule which is inhibiting this aldose reductase, so stopping the glucose from transforming into sorbitol. However, it's also very hydrophobic. Therefore, it's not easy to get to the place where it needs to be. We have devised a couple of solutions. The first one is niasomes. Niasomes are bilayered vesicles. In this case, I'm showing you a single-layered vesicle, which is called a micelle, but the principle is the same. You have the hydrophobic group and the hydrophilic group. The hydrophobic group doesn't like the water, so it gets together. And we add cholesterol and dotma to make sure that the resulting vesicle is cationic and repulses each other and has a strength to stay the way it should be. And then tween, polysorbate 60, is our main surfactant. The way we make it is pretty simple. We solve everything in an organic solvent, evaporate the solvent, then resuspend everything in water, sonicate it with the drug, and as you can see, you get some beautiful bilayered vesicles where inside of the bilayer, the iparostat will be found. And this can just be put into water and put into eye drops. Therefore, we have our first topical administration of iparostat. Secondly, we've also thought about oleogels. The beauty of oleogels is they're made out of oil. Therefore, hydrophobic molecules have no problem getting inside of them. But for oils to work, we need a gelator to create the oleogel. We use beeswax, cocoa butter, or ethyl-cellulose to make sure that the gel we get has enough solidity. The oleogels that we get are pretty beautiful, as you can see, and they release the drug bit by bit in a sustained manner. I hope that with this presentation, I have convinced you that topical administration is the future for ophthalmic medicine, and that we'll get to a future where diabetic patients won't need intraocular injections anymore. Thank you very much for your attention.